sample size by quartering method and determination of specific gravity, water absorption, moisture content, and densities of coarse aggregates.
Yay!
Experiment procedures and specifications are in accordance to ASH2 T248, ASH2 T85, and ASH2 T19. Quartering method is an alternative method of reducing the size of a bulk aggregate sample where a sample divider or refill box is not available. In this method, it reduces the sample size of a coarse aggregate without creating a systematic bias. The materials and equipment used in this experiment are flat edge shovel, container for testing sample, sieve number 4, balances and scales, drying oven, and most importantly, the coarse aggregates.
So first, we will gather our coarse aggregate samples and put it into our big tray or a clean, flat, hard surface.
Place the original sample on a hard, clean, level surface. Then, mix the material thoroughly by turning the entire sample over with a shovel at least 3 times. Carefully flatten the conical pile to a uniform thickness and diameter by pressing down the apex with the shovel so that each quarter of the resulting pile will contain the material originally in the pile.
Spread it evenly and divide it into 4 quarters and remove the diagonal section.
Divide the flattened pile into 4 equal quarters with a shovel or trowel. Remove 2 diagonally opposite quarters, including all fine material. Lastly, successively mix and quarter the remaining material in the same fashion as the original sample. Continue this process until the desired quantity is obtained.
Sieve the coarse aggregate using sieve number 4.
Wow!
Do a smile all throughout.
After sieving the sample, wash the aggregates retained.
Immerse each sample within 15 hours.
Yo! Hey, welcome to the video.
After getting the submerged aggregates, place the entire sample in a container and weigh in water.
Remove the sample from the container and drain any excess water from the aggregate. Using an absorbent cloth, roll the aggregate until the surface water has been removed. Then, weigh the saturated surface dry sand.
Put the quarter samples in the container.
This one.
Dry the sample in a pan to a constant weight in an oven for 24 hours. After 24 hours, cool it in air at room temperature for 1 to 3 hours or until the aggregate can be comfortably handled. then record weight as oven dry weight. Calculate the needed data. In calculating the needed data, we would be determining 4 of the properties of the coarse aggregates. Number 1 would be the specific gravity. Under specific gravity, there are dry relative, saturated surface dry, and apparent specific gravity. Second property would be the moisture content. Third property would be water absorption. And last property would be density. And under density, there are normal density and the bulk density. Results and discussions. Here's a tabulated data of the mechanical properties calculated from the sample. Specific gravity. The coarse aggregate sample has a dry relative specific gravity of 1.373, indicating that it is relatively porous and may have high water absorption capacity. The saturated surface dry specific gravity is 1.405, which accounts for the water absorbed by the sample, while the apparent specific gravity, which accounts for the volume of the pores, is 1.418. According to these findings, the aggregate sample has a moderate to high porosity. These results indicate that the aggregate sample has a low or moderate water absorption capacity that can be considered relatively dry. Moisture content and water absorption. The moisture content and water absorption of the aggregate sample are both 2.31%. Based on the results, it indicates that the aggregate sample has a low to moderate water absorption capacity and can be considered relatively dry. Density. The density of the coarse aggregate sample is an important mechanical property as it affects the strength and durability of concrete made with the sample. The normal density of the aggregate sample is 1,454.1 kg per cubic meter, while the bulk density is slightly lower at 1,453.43 kg per cubic meter. The difference between the normal and bulk density can be used to estimate the porosity of the coarse aggregate sample. In this case, the difference is small, suggesting that the coarse aggregate sample has a relatively low porosity. In conclusion, the results of the aggregate sample mechanical properties analysis presented indicate the sample has a moderate to high porosity and a low to moderate water absorption capacity. The sample is relatively dry and has a normal density of 1,054.1 kg per cubic meter and a bulk density of 1,453.43 kg per cubic meter, suggesting a relatively low porosity, which is desirable for concrete mix design as it can lead to increased strength and durability. Furthermore, these results can be used to select and design concrete mixtures that meet specific strength and durability requirements. In addition, careful considerations of these properties is crucial in the selection of suitable aggregates for concrete production. Experiment 6 is brought to you by Saludes, Giling, Maglunsod, Oro, Marfori.
See you on the next video. Bye-bye.